Hello, researchers. My name is Malcolm Shambana, once again to take you in research methods. And today we are looking at data analysis, and to be specific, we are looking at quantitative data analysis. Quantitative data analysis is wide and it cannot be covered in one session. So we are going to distribute these sessions in two parts. The first part, which we are going to cover, is descriptive, statistical, quantitative analysis. And then we will do another session, which is a bit longer than the descriptive statistical analysis sometime later on. Not today, of course, but sometime maybe days after this session, after you absorb this session. So sit back, relax, enjoy yourself, enjoy whatever you makes you comfortable. Is it a drink, a coffee, whatever makes you comfortable to listen to this session. Thank you. So, like I said, my name is Malcolm Shambana. You can catch me on plus 260-977-488-442. You can send me text or WhatsApp through that line. That's a Zambian line. You might as well subscribe to my YouTube channel. There are a number of videos there. So once you subscribe, you'll be getting notification if there's anything new on the YouTube channel. And you might as well like the videos so that I'm encouraged to bring more messages regarding this subject. Thank you. Objective for our today's session is to understand what quantitative analysis is, to understand what descriptive statistics is, also to understand the measure of central tendency, measure of variability, frequency distribution. Part of our research where most students are not comfortable with dealing, which is the quantitative analysis, because there are figures involved. But this session, we are going to simplify quantitative analysis. It's basically simple as long as you take it step by step and understand the logic behind every activity in quantitative analysis. So what is quantitative analysis? Quantitative data analysis is a systematic process of examining, interpreting, and drawing meaningful conclusion from numerical data. You have to interpret the data, develop an understanding of the data which you have been given. Definitely the data is numerical. You are looking at numbers. You have to come up with a meaning from that, from those numbers. And usually it involves the application of statistical methods, mathematical models, computational techniques to understand patterns, relationships, and trends within data sets. I picked this part from 8/10/2023. So what you need to bear in mind is that there are statistical methods and mathematical modules, other computational techniques which you need to employ in coming up with a meaningful conclusion. Statistical methods has been made simpler. You don't have to do manual computations. Even mathematical models have also been made simpler. You don't have to manually do your mathematics because there are applications, apps, which you can use. Even in Excel. Personally, I've found Excel very useful. You can use Excel to come up with end figures within your data set. Is it the mean or the average, or what you call it, the mode. There are now tools which can help you come up with those figures. But what you need to bear in mind is you need to know how to interpret those figures. What's the meaning behind the mean, or the mode, or the median, or the standard deviation? You need to know how the meaning, what that figure represents. Two techniques are used in quantitative analysis. We have descriptive statistics and inferential statistics. Descriptive statistics is the one we are going to handle today. We can't handle both of them, they are wide topics. And then inferential statistics will be handled in the next session. It's probably wider than the one we are handling today, the descriptive statistics. So what is descriptive statistics? Remember, we mentioned that there are two types of statistical approaches which are mainly used in your academic researches when you are dealing with quantitative analysis. And we mentioned descriptive statistics and also inferential statistics. Descriptive statistics, that's the one we're handling today. Inferential statistics will be handled in the next session. So now our session is concentrating on descriptive statistics. Descriptive statistics summarizes and describes features of a data set. It looks at the characteristics of the data, the numerical data you have collected. What are the features? It describes what that data appears to be. There are three basic categories of descriptive data. We have measures of central tendency. We have measures of variability. We also have frequency distribution. Measures of central tendency is a branch of descriptive statistics. Actually, let me say it's a widely used branch of descriptive statistics, which describes data set by identifying the central position of that data. So in this case, we are trying to look at the central, the common characteristics of that data. Something which appears in the middle of that data, maybe something which occurs frequently in that data. Figures which come often, or maybe are central or common within that data. So examples of central tendency are the mean, median, and mode. What we are looking at is basic statistics. So if in your career you haven't really done basic statistics, I think you need to go back and try to revise a bit, because I remember items like mean, median, and mode are usually taught even at primary level of education. I've seen where you do, I saw what my son was doing, tallying. My son is in grade 3. Already they have been taught how to tally, how frequent a figure comes, or how often a figure is appearing. They are taught that. So this is what now you can also use, imagine, in your academic research at university level, be it at master's or your first degree. This is basically talking about the mean, where we are measuring the average of figures. Mean is usually computed by adding the sum of the population, or maybe if it's a sample, it can be a population or a sample, adding the sum of those figures and dividing by the number of elements. So in our case, I've given an example there of figures. We have three. I'm assuming this is the age of, say, the pupils in grade one. And no, not grade one, Maybe in a class. Let me just generalize it. Maybe ages of pupils in one class at church. Let's say at church, where we have got a wide range of age groups. So we have the first pupil to be asked the age said 3, the second pupil said 4, third said 6, the other one said 2, the other one 7, the other one 3, then the other one 3, then the other one 4, then the other one 5. Those are ages of a class at church. So now, for you to find the mean of the age in that class, you need to sum up the mentioned ages and divide by the number of pupils in that church class. So when we sum up, we add those ages, then divide by the number of pupils in that class. So this will come to a mean of 4.1. Now we are talking about age, years, how old the kids are. We can never have age which is 4.1. Yes, it's possible, but now we're trying to be practical. So we round it off. Definitely, we round it down to the nearest whole figure, which is 4 years. So the mean age in that class is 4 years old. That's the average. That's what mean represents. That's the average. So this shows that mostly when you pick a pupil in that class, mostly they are near 4 years old or 4 years old. That's what the mean implies. So this mean can be used in your research to determine the most common response, maybe from your respondents. For example, if you say if you computed answers on the most common cause of gender-based violence in Zambia, if you had already set up the themes, you already had a theory which you had set up, and then people had to pick from your theory, then you pick the number of times each theory appears, then you add those, then you find the mean, in short, the common statement. Still on central tendency measures, we come to the median. The median identifies the number that falls in the central when figures are arranged in order. So in our case, we have 3, 4, 6, 7, 3, 3, 4, 5. We can rearrange this in order. Comes to 2, 3, 3, 3, 4, 4, 5, 6, 7. This is when now you choose the number which is central. This is more like it's a physical, you don't need to compute. This is a physical activity. You choose the number which is in central of these. So remember, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 figures. So the figure which is in between is the fifth figure. So the figure which we have here is 4, this one. Once we pick 4, we will have 4 this side, 4 figures this side, and 4 figures this side. That doesn't imply that when I've picked 4, that implies that this side has to be 4 and also this side. Is this just a coincidence that we have picked 4, which is in the middle, and there are 4 these figures this side and 4 figures this side? I'm just trying to be symmetrical, trying to be in between. So our median in this case is 4 years. That's our median age in this class. We are still on the measures of central tendency. We come to the third one, the mode. The mode measures the most frequent number, the number which appears most of the time, or the response that appears most of the time in your research, the response through maybe your questionnaire, whatever tool you are using, the most common response, which of course which has to be quantified. So in our case, I'll use this table to analyze the frequency of each, how many times each particular age is mentioned in that class. So we have got age 2, it was mentioned only once. Age 3 was mentioned 3 times. Age 4 was mentioned twice. Age 5 was mentioned once. Age 6 once. Age 7 once. So the most frequent number or age in our case is 3. So the mode measures the most frequent age or most frequent response. So all in all, the measures of central tendencies tries to look at the common central response for you to come to a conclusion. This is basic statistics. So it actually responds to your questions that are basic within your research, maybe demographic part, where you're looking at how many ladies, how many women, or how many gentlemen, or what age group. It's about grouping. Just maybe you're gathering information for your demographic purpose. Thing you need to bear in mind when using these 3 measures of central tendency, which is the mean, mode, and median, you have to ensure that your data is normally distributed. What I mean by normally distributed is that your figures or your numerals don't have to be extreme. They have to be symmetrical. They have to be close, maybe close to a particular point, not really scattered, maybe having extreme figures like you say, for example, within the age, there is 2, then you have 15, then you have 30, then you have 1, then you have 200 and something, although there is no such age, but that's for data purpose analysis sake. It has to make sense. You have to have figures which are related, which are normal. They make a normal shape. Otherwise, you are going to, if you use a measure of central tendency, you are going to jump into wrong conclusion. Because if you have figures like 2, 15, then you have 60, then you have 110, it's very difficult. Your mean won't represent that class of that population you have picked. The mean will be extremely different from it won't even be close to those normal figures which are within the population. The mean might, if, for example, if you had 2, 15, you have 75, you have 110, the mean may be even be a figure which is maybe 80, which is not close to 2 or close to 110. So you have to ensure that the data is closely related. It's normally distributed. That's the key thing you need to ensure. So before you even start doing your measures of central tendency, you need to plot the data to ensure that it is normally distributed. Our data here in this graph, it was closely normally distributed, but this was for illustration purpose. The data was too little, that's why it appears like that. But still, it shows that from 2, there is a 3, there is 4. They are falling within the normal, they are close to each other. The extreme one is a 7, but which is not bad for doing our central tendency measure. So you need to plot your data, see if it's making sense. That's when you can apply the central measures, because you want the mean, you want to know what that mean is representing. But if the data is not normally distributed, the mean you are going to compute will not represent that class or that population you are trying to make a conclusion on or assess information on. Remember, we are still on descriptive statistics, and we mentioned that under descriptive statistics, we have measures of central tendency, which is mean, median, and mode. We also have measure of variability. We also have frequency distribution. So we are now on measure of variability. Variability refers to the amount of spread of scores around the mean in a distribution. So we are looking at how your data is spread. Where are your scores falling? Where are your edges for your pupils falling? How wide are they covering in terms of figures? So variability is most commonly measured by the range, which checks out the difference between the highest and lowest score. So in our case, we are looking at the oldest in the class and the youngest in the class. So that covers our range. What's the range of the pupils in our class? So in our class, we have this range, which is 7 years. Remember, we had 7 as the highest, as the oldest, the 7-year-old. And then we also have the 2-year-old as the youngest. So the difference, the gap, it shows us the gap, what age our class is covering. If we had 10 years and 100, it would have been 100 minus 10, which would have been 90 years. How the age group would be spread between 10 up to 100, and the range would be 90 years. So in our case, the range is 5 years. So the difference between the oldest and the youngest is 5 years. So the gap is 5 years. Then we have come now to the most important variability measure, and it's the most common at descriptive level of statistics. And this is not easily computed like the way we have done for the range. There are several formulas which are used for the population and also for the sample to determine the standard deviation. However, with modern technology, you can input your statistical data. It will give you the mean, It will give you also the standard deviation. The standard deviation measures the average distance of your scores, of your edges from the mean edge. So remember our mean edge was 4. So we had also edges like 2. So between the difference between 4 and 2 is 2. We also had edge of 3. The difference between 4 and 3 is 1. We also had the edge of 5. The difference of 4 and 5 is 1. We also had the edge difference of 6. The difference of 4 and 6 is 2. We also had 7. The difference of 4 and 7 is 3. So now you get those differences and find the average. Remember, we did the average, which is the sum divided by the number of elements. So this is done statistically. You can use an app, you can use Excel. Myself, I used Excel and found out, using the same data we have there, and found out the standard deviation is 1.62, which makes sense if you round it off, because age cannot be 1.62, remember? You have to round it up, so which is 2. So the standard difference, the most common difference between the mean, which is 4, and any other age is 2, the common difference. So the common which makes sense, most people were falling between that range between, the difference was between 2, which is, I wish I could go back to the graph. Let me look at the graph. So most people, the mean is here. We have put our mean here. So most common difference is 2. Here there is 1. Between 4 and 5, there is 1. 4 and 3, there is 2. Sorry, 4 and 3, there is 1. 4 and 2, there is 2. 4 and 6, there is 2. 4 and 7, there is 3. Now, the average of those is the most common difference, and that's the standard deviation. That's what they call standard deviation. The common distance between the mean and any other age. That's the most commonly used measure of variability. You're looking at the difference. What could likely be the age difference from the mean? What could likely be the age which we can pick if we haven't picked the mean? Most likely it will be maybe between, it will be 6 or 2. It will fall within that range. That's what the mean implies in our case. So we move on to our third type of descriptive statistics used in your quantitative analysis, which is your frequency distribution. In this case, frequency distribution displays the number of observations within a given range. So you choose or compute a range in which you put your population. You can choose, say, between the ages of 1 to 5, I want to know how many people are there, or between the ages of 6 to 10, I want to know how many people are there between the age, and so on. You group them in a common range of ages so that you assess how many people are within a certain age group. So, for example, here I have age from 1 to 5, then I have, suppose actually to be 6 to 10, maybe also from 11 to, because we are looking at different age ranges. Those ages are grouped, and then you find out the number of elements within each range. In our case, we have grouped ages, and then we have found out that how many people are in between age of 1 to 5? There are 5. How many people are between the age of 6 to 10? Ignore the figures at the bottom. They are not, I think, representing the correctly arranged age groups. It's supposed to be 1 to 5, maybe, and then it's supposed to be 6 to 10, then 11 to 15, then 16, and so on. So this for illustration purpose. So that age range has its own frequency. So if a person is between 2, he will fall in that range of 1 to 5. A person is between 3, you fall in the range of 1 to 5. If the person is 7, you fall in the range of 6 to 10. That's your frequency distribution. It shows it's grouped. It's related to what we did with mode, but in this case, the data is grouped. It's a common way of representing your data to find out how the pattern falls in your descriptive statistical analysis. So hope this descriptive statistical analysis opens up your mind once again. It's a refresher course from what you did at primary level, but it's something which you can use in your research at masters, even at your doctorate level, even at your first degree level. It's very important, even though you learned it at a very tender age. I'm sure most of you did learn this. So from this point, our next session will cover inferential statistics, which looks at if this descriptive data which you have gathered truly represents the population. We are assuming that this descriptive data relates to a sample. So we want to find out if this descriptive data truly represents the population. If this descriptive data at a school you have sampled surely represents the population of the entire school. If the mean age of 4 represents the mean age of the entire school, that's what we are going to do under inferential statistics. Thank you for being around this session. Hope you enjoyed and understood. If you haven't understood, you can always contact me especially in any area you haven't understood. Even on previous videos which I have done, you can subscribe to my YouTube account so that you can also be receiving latest information on this account. So I thank you all for paying attention.